feel bad that I'm up here holding you between now and the party. So I'm going to try and get through this really, really fast. If I talk too fast, just kind of wave me down a bit. Obviously, I've got a bad accent as well, so that's going to be a bit of a problem, as I've already been told. But yeah, it's really good to be up here. Really appreciate being up there. Are we good to go? Awesome. So, thank you very much for joining us. I'm going to be joined tonight by a couple of gentlemen, Jim Coleman and Srini from Philips Healthcare and Trimble. We're going to hear from them later on. They've got some really, really interesting use cases they want to talk about, and I'm sure you'll be excited to hear about. My name's Andrew Kiggums. I'm a software development manager. I've been working on this thing for about 9 months, so really excited to get out the door. I hope you were all able to catch some of the keynotes. You realize that we're really pushing a lot of new IoT features and services out to make everybody's life a lot easier. So today, we're going to focus on device management. We're going to talk about a bunch of stuff today. So this is your chance to leave if it's not what you're interested in. We're going to talk about some of the features of AWS IoT Device Management. We're going to talk about some of the use cases that people are having and some of the trouble they're having with IoT and how we solve them with AWS IoT Device Management. And as I mentioned, we're going to hear from Jim and Srini about how Trimble and Philips Healthcare have been using the features over the last little while. So, one of the things you have to think about when you're connecting your devices to the cloud is some of the problems it presents. Now, these aren't problems that haven't been solved before. People have been doing pub/sub for a long, long time. Sensors aren't new. But the game's changed a little bit. So these are still things that have to be solved. And one of the things that AWS wants to help you with is what we call the undifferentiated heavy lifting. The things that don't give you a business advantage, the things that just everybody that wants to get into this space has to do, such as security, right? Everybody needs the security. You want to make sure your devices are secure. You need scalability. You could argue you don't really need cloud integration. We'll talk about that in a little bit, but things have changed over the last 4 or 5 years. The things that we're doing with IoT now couldn't really have been done very easily, if at all. And Dirk Didascalco makes a great comment. He says there's 3 things that have changed. One is the mobile marketplace that have driven down the cost of chips. If you followed the keynote, we talk about increasingly smaller chips and FreeRTOS being able to be put on those very, very small chips. We talk about the cloud, and obviously, if you've been following AWS or a user of AWS, there's a lot of services. Part of those services is large amounts of computing capacity and storage capacity. That wasn't really available more than about 5 years ago. So suddenly you've got compute capacity. And now we've got analytics platforms, IoT analytics, for example, which allows you to do a lot of number crunching and digging into your data. Because there's another meta point. Nobody says, I'm going to buy IoT. You just don't do that. Yeah, IoT is a great thing, but it's a means to an end. What you're really trying to find out is, how can I use the data that's now available to drive better business decisions, to drive down my operational cost, and how to manage my devices in a much, much better way. Now, we've talked about some problems here, things you've got to think about. This gets worse with scale. How many people here have a smart device in their home? Maybe a lock or a light bulb. Yeah, a few. Very common. How many of you installed it yourself? Right, fairly straightforward. You get your app out, you fire it up, you smarten up your washing machine, or you enable your key. It doesn't take too long. Maybe, 15, 20 minutes? That's great. How many have more than one device in their house? Not really a 15-minute job, is it? Maybe spend the weekend getting all your light bulbs screwed in. So it's a lot, but it's still tractable. You can still knock it out on your own. Imagine you wanted to do that in a hotel here in Vegas. And somebody said, hey, you know, we want to improve our customer experience. We're going to put in smart light bulbs and a controller in the wall that's voice activated, lights on, light off. So he goes, yeah, that's great. We can do that. That's going to be a great customer experience. You know, voice activated control inside the room. Can you imagine what the operations manager in that hotel thought? Because he's just been given 5,000 rooms full of objects that he's got to install. And he's looking at several weeks of installing smart light bulbs. These are the kind of problems that scale brings. Security, another great one. If any of you have been following the security landscape recently, we had a massive DDoS attack not so long ago for an unsecured set of cameras. Sure, you can secure a server, but when you start throwing thousands and thousands of these things out, how do you ensure that they're all secured? We saw a security breach fairly recently where the Apache struts hadn't been patched. Now, you know, big company, tens, maybe hundreds of servers. But it's a hard problem, even at that scale. Now, you've got thousands and millions. So how do you make sure your devices are patched, they're up to date, they've got the latest operating system, and moreover, how do you find them? How do you get the data off them? Because there's millions of them. It becomes a very intractable problem without things like automation. And then, of course, as I mentioned, you know, once you've got your data and it's coming, you want to take advantage of the cloud. And that's some more problems. And we'll talk about some of the ways that we're helping these to solve getting your data in and out the cloud, taking advantage of services like S3, DynamoDB, Kinesis, pulling data into the back end. So there are a couple of features here we're going to talk about. So what have we built? How does it help you out? We think about this in kind of 4 categories. Onboarding, how you get your devices into the infrastructure. Organization, how do you group by feature, by version, by location, whatever's meaningful for your business. How do you monitor things on an ongoing basis? I have a security background. One of the big problems we see is that security, for instance, is not a point-in-time thing. Security decays over time. You have to have ongoing processes that are monitoring your devices from an operational standpoint, from an application standpoint. One of the things that requires is updates. So we'll talk a little bit about how we keep our fleet of IoT devices updated. So let's start with onboarding. Onboarding, as we talked about, 1 device, not a problem. 12 devices, not too bad. Thousands of devices, millions of devices. We have customers recently that have come to us and said, hey, we've got these 10 million devices. We want to onboard next week. Before we did the device management platform, we'd gone, it's going to take a little bit of time, but we can do that. Now, we can do it very, very quickly with thing registration. Thing registration requires 2 components. What we call the provisioning template, which is a description of what your device looks like, or your group of devices, and a parameter file that describes the individual devices. And when you couple those 2 things together, the description of all the parameters, and then a resource file that describes those things, suddenly you've got a very, very scalable solution. Jim's going to delve into that a little bit more and tell them how that kind of thing's helping out. And obviously, this resource file is a single thing, so these can be very, very long depending on how many things you want. So you've described your thing. How do you get them on board? So if you're familiar or if you've used IoT at all, you'll know that there's a couple of ways that you can use to authenticate your devices or things. One of them is obviously the X509 certificate, very well known, very well understood pattern for device identification. Really, it's identifying the TLS connection endpoints, but for this purposes, it's exactly the same thing. The other way is using SIG-v4 credentials. If any of you have actually cranked up the AWS CLI or anything like that, you'll know you can generate credentials, either permanent credentials or temporary credentials. So they're the common ways. Good, but not quite good enough, because there's a couple of classes of customers out there that this doesn't work for. The first class of customer is obviously the customer that doesn't want to use these mechanisms. Maybe they want to use OAuth, or maybe they want to use JWT tokens. For whatever reason, maybe it's space on the device, maybe it's a legacy system, older style devices that they want to onboard into IDEA. They need support for us. The other customer is the one that's gone down the track of building their own systems and their own authentication mechanisms. Srini is going to talk you through how that works for Philips Healthcare that have been in this business for a long time, and that's exactly what they wanted. They wanted us to build a custom authorizer. And what the custom authorizer does is it allows us, AWS IoT, to accept arbitrary tokens and connect it to a custom backend via the use of Lambda to authenticate your connections on the fly through something that's designed by the customer for the customer's use. So that's very powerful. You can hook it either to unique EC2 instances where you stand up a new server, or you can backhaul it all the way to your own data center and couple it directly to your authentication mechanisms. So that's great. You've authenticated and you're into IoT, but hey, you want to use other services. And one of the problems is that many of the small constrained devices don't even have enough room for 2 authentication mechanisms. Or, from an operational standpoint, you just don't want to handle yet another set of credentials. You've got an X509 certificate, you don't want to have to deal with AWS SIG-v4, you don't want to deal with temporary tokens. So, we developed X509 native support. And what this allows you to do is use your X509 certificate and swap it for credentials that allow you, for a limited amount of time, to let that device access. And of course, it comes with all the usual stuff from IAM, policies, durations, what have you. A couple of use cases. One of them is driven internally. Is streaming video. And what that means is that the control plane can be over MQTT, but that massive amount of video can be streamed, for example, straight into Kinesis. Honestly, MQTT is not really good for streaming data, small packet size, so there's other AWS services that are much better at this. So at this point, I'd like to hand over to Jim, who's going to walk you through Trimble's world, some of the use cases that they're supporting, and how AWS Device Management has helped them out. Jim, thank you.
Thanks, Andrew. Thanks, Andrew. Hello, everybody. Good evening. Truly the hardcore here tonight, right before the party.
Green button.
Green button. Here we go. There we go. So yeah, my name is Jim Coleman. I am engineering director with Trimble. If you're not familiar with Trimble, we are a Fortune 1000 company with product reaching in over 150 different countries. So if you look at our brands, our joint ventures, and our partners, you maybe get a sense of our technical diversity. So one of our long-standing core competencies is positioning and positioning technologies. So we'll marry up things like laser, optical, inertial, mixed reality, with wireless comms, and eventually stuff that data in some cloud. In effect, what we're doing is we're connecting that physical world to the digital world, which creates a very broad opportunity for IoT and IoT data. So getting specific, go through a couple of high-level use cases and how AWS is helping us out. We've got a truck. In fact, we've got a fleet of trucks. So the use case goes something like, as a fleet owner, how do I get data from my fleet that's going to help my business? I want to do things like know the fleet location. I want to know fuel consumption. I want to automatically construct driver logs. That's a big thing right now. I want to do even some data discovery using analytics. So as a solution provider, how am I going to help this guy? Clearly, this is IoT, so we need sensors. We've got a ton of those. But we also need an infrastructure, something that's going to help deal with those thousands of connections, the parsing, the messaging, and the data management itself. What I'm talking about is a basic IoT pipeline. Ours breaks down into something like this. So we have data ingress, we have parsing, messaging, and then storage and display. So if you look at this, it's good. We've been doing IoT for a long time, but there is one problem, and that's going to be the VPN. VPN is great. It gives us that extra layer of security, but it's an extra layer, and it can be a NetOps choke point every time you want to add a device. So we're constantly trying to do better. How can we do better? Well, we went with AWS IoT and X509 certificates. We used that plus the open internet, and we were able to completely eliminate that NetOps layer. We can better scale, we can onboard devices faster, and provision them faster. Big win for us. But let's keep going. How else can we improve? So device management and provisioning is actually an IoT necessity. This is not a secret in the room. In Trimble, we actually have quite a range of how we do this stuff. So we do either the high volume third-party chip manufacturers, or we can go to the lower volume internal fulfillment centers. AWS Device Management helps us actually in both cases. So just really quick, we actually incorporated the device management into the high volume fleet setup. And the big win for us right out of the box was an increase in, we retired code and got development velocity out of it. Excellent. As a manager, I love it when that happens. But the bigger win, which we didn't predict, was about a 4x increase in our device provisioning throughput during production. So again, as a manager, this is actually quite good. And we did this just by implementing the service. So as you can see, the eye chart here, we've got a ton of devices, there's a ton of features, and as we go down that list, I'm getting more and more confident that the AWS device management is really going to work out for us. And we've barely scraped the surface. Overall, almost all of Trimble business areas rely on mapping that physical world to its digital twin. And therefore, we put a lot of focus on data. That said, we view IoT as a means to an end, but not the end itself. As AWS IoT Core continues to grow and overlaps with our own collection of microservices, we're happy to let AWS take on that undifferentiated heavy lifting that I'm sure you've heard about. After all, we want our resources focusing on customer value, not maintaining and managing an IoT backbone. And with that, thanks, and I give it back to Andrew.
Great. Thanks, Jim. And I think that, that's a great showcase for the ability to speed up and get automatic improvements simply by moving on to the platform, the ability to cut out that layer of onboarding and speed up your pipeline, that's operational saving right there. And obviously, as Jim said, the undifferentiated lifting allows them to focus on their core. Their core is not IoT, and I think you'll hear that. That's something we hear certainly time and time again. Yeah, we have to deal with it. Really, we'd rather not. We got a lot of smart people. We want our smart people working on our business, not supporting our IoT infrastructure. So you've got yourself onboarded. You've got millions of devices, and that's a problem because now you've got these huge numbers of devices that you have to manage, and you've got operational problems, or maybe you've got to go and dig in to find a device that you're interested in. Maybe it's a customer support issue, maybe it's a security issue. So you want to be able to dig in. And one of the things that we've done is giving you the capability to group like objects. For example, maybe it's by region, maybe it's by type, release number, functionality. And that's called thing groups. Now, thing groups is a hierarchical system. As you can see, I've just got 3 hierarchies in my light bulb system. I've got location, then I've got a subdivision of floors, basements, and roof, depending on where they're actually located, subdivided into guest rooms and rooms. And I can put my things into multiple groups. The way I've divided them up is by type, because maybe I have to treat them differently, depending on what attributes they have. Maybe I try to turn off my incandescent bulbs as often as possible because they're power hungry. They generate a lot of heat, drives up my AC bill. The other advantage, or one of the big advantages of this, is the ability to apply policy. Why is that interesting? Well, up till now, you've been able to apply a policy to an individual thing, which is really, really powerful because you can get very fine-grained control. The flip side of the coin is, however, you have to put a policy in everything. So that means you've got 1,000 relationships to deal with, which is not necessarily efficient. So what you can now do is you can attach policies to groups. So I can decide that this group I'm treating in this particular way, I'm giving it these particular capabilities, this particular access control, very like you would in IAM. Why do you create a role in IAM? You create a role in IAM because you want a lot of people to be able to use it. Otherwise, you would have to give the capabilities to every single people. This is the same model. I put my policies on the group, and I put my things in the group. We can quickly walk through how this works. So, first thing, location. I've got a policy on my location, and the policy says, my thing can subscribe to the administration topic. Basically, I can reset it, I can upload new software to it, power it down, whatever it happens to be. The next thing says, if the light bulb is in a guest room, I want to know what the status is. You'll notice we still support variables, IoT variables in here, so you can, tune your policy to be more specific, even though it's attached to a group. And then maybe I've got a topic specific to that room. Maybe the local light controller subscribes to this so that they can be synced up. And then just like we do with IAM policies, we stack them up. So now I've got the effective policy for my individual thing based on the hierarchical group membership. And a thing can be a member of multiple groups, so you can carve it the way you want. Maybe you can have it by region, by ability, and by version simultaneously, and treat that. And we'll come back to why you would want to do that. So we've kind of organized all our things. We've got them into the groups. Awesome. What happens if I want to find an individual thing? This is powerful. Until now, IoT has been really stingy with the number of attributes you can search on. You can count them on one hand. Which is great if you've only got 3 things, but when you've got millions of things, 3 attributes really doesn't help you out. So now, what we've introduced is fleet indexing in search. I'll show you how to turn it on, but essentially, what it does is it indexes your device registry and your shadow, and then allows you to search. So we've got 3 queries, kind of Lucene-like. I can say, give me all the light bulbs before version 6 because I'm going to upgrade them. Great. But I can couple that with the state of the device and say, show me all the lights that are currently on and there's nobody in the room. by coupling those two together, both the attributes of the device plus the state of the device, I can now make really interesting decisions. I can say, tell me all the lights that are on of this particular version of software, but there's nobody using them. Because one, I can turn them off, save some energy, but now I can upgrade them without any impact. When I was putting this together, I kind of thought, wow, that's actually better than I thought, because one of the problems in my household is, just as we're about to go out the door, to restaurant, wherever, my girlfriend says to me, oh, I'm wrinkled, I need to throw this in the tumble dryer to get it straight. So you can imagine, if you throw your clothes in the tumble dryer and the tumble dryer suddenly switches off because it's being upgraded, not a great customer experience, but you can now tailor the actions of your devices based on what's happening in real time. So that starts to get really, really powerful. Of course, now you've found your devices, you want to start monitoring, seeing them what they're up to. And I think one of the things that we also want to do, coming back to that group, is be able to decide at a group level how much information I want. Because as we get into, I mean, I don't know how many guys use CloudWatch metrics? A lot of metrics, right? I don't know, how many instances, maybe you've got 100 instances, 1,000 instances, something like that. And it starts to produce a lot of logs. You start to put them in S3, it starts to get a little bit spendy, so you've got to be careful about what you're actually logging. Now multiply that by 1,000. Where does that take you? Not great. So what we are doing now is introducing fine-grained logging. And fine-grained logging allows you to tune the logging level that you're interested in. So in general, if everything's going fine, you turn the knob way, way down. And you're just getting the minimal amount of information to do your operational job, your security job, whatever it happens to be. But you know, something happens. You've got to dig in a bit deeper. Maybe you've just deployed some software, a certain group of devices isn't behaving properly, and you want to dial it up a bit. So at a group level, you can say, right, give me more information. Give me debug logging or error logging. Of course, it goes to CloudWatch, which is great. The next problem with that was we had text-based, which is great for humans, but hard to automate. So for fine-grained logging, we're also introducing JSON compatibility. So the logs being put into CloudWatch with the new logging system will be JSON formatted. And now you can stick that into any old JSON parser, stick it into a database, and really start doing some interesting searches into your logging system. So you've got your logs, and you've found out there's some things you want to dig into, and you want to automate this, right? Because as I talked about earlier, manual processing just isn't feasible. So we wanted to enable the ability to start taking a more DevSecOps approach, where we automate the things that we do manually over and over again, or the things that are hard to do manually. So we've built an event system. A couple of examples, we're going to talk about jobs in a minute. Events will trigger on certain activity inside your IoT system. In this case, maybe somebody's joined a group, or there's been a policy change. That's going to publish to a topic that you define. And if you're familiar with the rules engine, once you get something in a topic, you can start doing a lot of stuff with it. You can put it into a database. You can send yourself a text message. You can stick it into SNS, SQS, what have you. And what that lends itself to is automation and response. For example, updates. One of the big problems we hear all the time was, you know, I've got all these devices out there. They're all at different rev numbers. They're all in different locations, different time zones. I need to be able to update them. I need to be able to configure them. I want to be able to get telemetry. I want to patch them. And if anybody of you dealt with large groups of servers, that's a really hard problem just to know exactly what the state is, to keep them in sync over time, because these things drift. Common problem. I've got 100 servers. One of them's down. Bad disk. But I've patched all the rest of them. Oh, forgot about that one. So you've got an unpatched server. So what you get over time is drift. With jobs, what we want to allow is you to have scheduled or continuous ongoing jobs to handle these cases. It might be patching, it might be updating, it could be any of these things. If we think about the query we ran earlier on, get me all the light bulbs that are off, I can use groups to handle this problem. I can create a group just for patching, and I can run what's called a continuous job. And a continuous job is something that you attach to a group, and when anything gets added into that group, the job runs. Now, the jobs are arbitrary. We don't put any constraints about what that job will do. But we do track it and provide status. So when I add my job in to my patching group, it automatically triggers an action to do some sort of behavior. Maybe it's just analyze the state of the thing. Big use case. White good manufacturers, probably not making fridges in America anymore, sad to say. So what happens is they get made, maybe in China, maybe in Taiwan, and they get put on a boat, and they spend a couple of weeks coming across the Pacific, and they arrive in Seattle. I've seen them, I know them. There's thousands of these things just sitting in containers all the way along the dock front. And they'll sit there for a week till they come out of customs, and then they'll get put into a factory, into a warehouse somewhere, and eventually they'll make it onto the floor at Home Depot. And then maybe they'll sit there for a few weeks. And since that thing's been manufactured, till it actually goes into somebody's house, it could be months. What's happened in that intervening time? Have we found a security flaw? Have we released new software? So the first thing you want to do when that thing comes up is get it up to date. Jobs will help handle that for you. Of course, there's some things you want to be able to do. You want to be able to control the velocity. How many people have, and I hate to use it, Apple iPhones? A few, right? So you know when you hit that I key, you get some kind of symbol that looks like Prince, right? Not great. One of the things you want to do is avoid that kind of thing. So you can use things like velocity to do a small sample size. Let's see if we put it out, maybe just in a few devices. It's something that we do at AWS. When we do an update, we don't push an update worldwide instantaneously, right? That's just not the place you want to be in. We put out a small one, we make sure it works. We put out a few more, we stick it into maybe, US West 2, or maybe US East 2. Bring it up there, see how it behaves. Okay, looks good, send it worldwide. So using velocity and priority, you can control how your deployments go out, how your patches go out, how your configuration goes out, and then use the status mechanisms and the event system that we talked about earlier to control and monitor the status of those jobs. So you can know at any point in time who's got the deployment, who's got the configuration up there, where it's deployed, what's the completion. So these are some of the things that the jobs platform allows you to do. And I'm very happy to invite Srini up onto the stage to talk about some of the things that Philips has done and is doing to leverage AWS IoT Device Management. Thank you, Srini.
Thank you, Andrew. How many of you are excited with the features that Andrew talked about here? Yeah. That's good. And how many of you are here from healthcare? Well, that's good hands. So we'll do a little exercise. I would like you to put down your phones to the side. Look to your left. Look to your right. 1 in 3 of us is going to be diagnosed with cancer. Sorry to say that. So Philips is a globally known brand, and Philips Healthcare, we focus on patients, providers, and medical devices. And this exercise actually was done in last State of Union for IoT last year. So today I would like to talk about our journey that Philips has been doing in bringing AWS IoT Device Management and expanding our platform in bringing Philips remote services closer to our customer care. So Philips Health Suite is a suite of services that we have built. It's a cloud-based platform that provides capabilities in building applications that actually connect the patients and these providers for a seamless experience. This platform actually supports plethora of devices that needs connectivity for 24/7 and actually helping healthcare providers in finding out the optimized performance or how their clinical devices are being used in the field. So Philips has been connecting these medical devices for over a decade. So many of our devices today in healthcare providers actually do connect to internet. So in IoT for Philips is more of getting intelligence into those devices as we connect them into our platform and get that device diagnostic data and that usable data that allows us to actually help our healthcare providers to better their business models and also reinvent the customer experience. In Philips Health Suite Connect, we have been doing device management, and one of the key capabilities for us is to be able to connect these devices to the cloud, let them discover the capabilities that they have. And in the end, all of this we have to be doing, we have to be able to do it in a very secure way with the flexibility of us being able to make firmware updates when needed at the right time, and also lowering the cost for maintenance. And this whole thing has to be done at the global scale that Andrew was talking about, and this is what Philips does on a day-to-day basis. So the platform actually allows our business groups or various modalities to actually onboard and organize these devices into a device hierarchy, which internally Philips business groups have this device hierarchy that they have been built over many years. There are many different types, many variants. Every device that gets shipped to a separate healthcare provider can potentially be of a different device type because of the customizations. And these devices has to be authenticated to our identity access management within Philips. And because we are in healthcare, it is very key for us to authenticate these devices for a secure connectivity. And in the end, we have those devices to be integrating with other existing services. Like as Andrew was talking about, there is no one integration, but there are multiple integrations that we normally see in getting these devices connected into the platform. So what we see here is the group of services that we have envisioned over last year or so with our new platform, where we have a global master data that allows various business groups within Philips to organize their data, their configurations. We have the discovery service that allows these devices to discover what services capabilities are enabled. We have the provisioning service that allows these devices that have been shipped into these healthcare providers and connect into our platform in a secure way. And on the bottom, you see the core capabilities that we need for our Philips remote services to be able to do firmware updates, have a good digital twin in the cloud using the device profile service that knows exactly what is the firmware status that is available on the actual device, not what is the configuration that the device should be having. And also the device control service that allows our Philips remote services to be able to send these control messages for either a remote connection that needs to be open to that device. We also have the key capability of a data broker that allows our devices to connect through the MQTT gateway and be able to push the data, this small telemetry data. And also some devices have this large logs, binary data that we push into blob repository. So we have been using the AWS IoT core capabilities of device gateway and the message broker and rules engine over the last year or so. And all of these microservices actually have been built using serverless architecture, using API gateway, Lambda, DynamoDB, and CloudFormation for orchestration. And some of these capabilities are realized using the AWS IoT Device Management, like registry and jobs capability and the custom authorizer that Andrew talked about. So downtime is not an option in healthcare. So Philips recognized this long time ago, and it is very essential for these devices to be up and running. So one of the key use case is this remote service use case for Philips to help our healthcare providers in keeping those devices up and running for the premium patient care that everybody looks for. So as I was saying, these devices, they get discovered and provisioned into the platform. Once provisioned, they get authenticated with our identity access management, start sending in this device diagnostic data, which in our data broker, we apply IoT rules to actually query and filter some of these messages and be able to send alerts to our remote service engineers who can look at those alerts, diagnose these logs, and possibly, in this case, send a remote control message that can update the configuration on that particular device. And in the end, our remote engineers actually perform firmware updates over the air. So examples and flow diagrams are easy, but real world is hard. What I would like to walk through now is how we have our Philips devices that actually have to authenticate with our platform using Philips Identity Access Management. And most of these devices that exist in the field out there today actually can connect via internet using the standard HTTPS REST services. So we have built many of our services using the serverless stack, which uses Route 53 API gateway, and the existing custom authorizer that is there on the API gateway, which actually introspects our bearer tokens that is coming from this device to our access management, and that, based on the permissions that have been defined for that particular device, generates a policy, and that policy either allows that request to the business lambda or deny it. These identities that exist in our Philips IAM are also replicated back into the thing registry, along with the configurations that I talked about for these various modalities where the device hierarchy is replicated as thing group and thing type. Now what that allows us is, as more and more we see there is necessity for real-time event-driven kind of processing that is needed, we started using the IoT gateway capability. In this case, using the custom authorizer that Andrew talked about earlier, we now introspect the same token that is coming from these devices and generate a policy based on the permissions that are defined for them, and send it based on whether the policy allows for the device to be able to publish or subscribe onto a topic, and then forward the message to our business lambda, which in this case, we also use IoT rules engine as well as this business lambdas connect to the DynamoDB or persist in DynamoDB or push the data to S3 buckets. We also have used extensively the CloudFormation that allows us to orchestrate these orchestrate these services and take from one region to another region very quickly, and also from one stage in our software development lifecycle, from a dev stage to a user acceptance testing and production stages. One of the key features that Andrew talked about, which I'm also, we were excited about using that feature, is the jobs capability. This jobs capability actually allowed us to create, or system integrators to be able to define a job definition. And that job definition actually is in a JSON format. And that job definition contains the metadata, which includes the in S3 URL, for example, where the actual binary exists. And these jobs and the events that Andrew talked about help us in using the groups that have been previously created, and the system integrators using this job definition, creating a job, allowing this job service to actually notify the devices about a job definition that is available. And the same event service also tracks at the instance level the job execution, and devices can actually send back at what state they are in. And in the end, they also update back to our shadow, and which in turn will help us in looking at the device profile, what is the latest firmware status it is in. So for Health Suite, Connect, and the AWS IoT, it is always day one, as always famously quoted. We envision many more possibilities. It is in this journey and our partnership with AWS IoT, as well as we are looking for in working with other expanding our capability of the platform using fleet indexing or group policies. And we look forward to work with other partners of Philips where we can make this device management a seamless process. So with that, I would like to hand over back to Andrew. Thank you.
So there's a couple of things that I find really exciting about that. One of them is at my stage in life, I really expect to be taking advantage of a lot of these services very soon. So the fact that they're working is great, and I think we're very aware the baby boomers have got it coming. Unfortunately, I'm one of them. So this is great. The other thing is that I think it's a really good demonstration of how an existing system where a company's invested a lot of time and effort into building their own authentication system can move very quickly and efficiently into AWS IoT and take advantage of the things that we've built to help them. Because now, and again, this is very, very personal, they can focus on the stuff that lets me get out of my bed in the morning. And we're going to take away that heavy lifting that we talked about earlier, the data storage, the analytics, the upgrades. We got a little bit of time left. So one thing I did want to take a quick look at, and I'm going to just quickly run through the console to show you some of the things that we've done and how you might want to use them. Obviously, one of the drags of the console is that it's very much focused on individual tasks, and it's quite manual. But everything here is totally supported by our APIs. We've got SDKs around this supporting. We've got a jobs SDK that you deploy on your devices. We've got our AWS IoT Device SDK that you can use as reference architectures, and there's plenty more coming. So one of the things I want to talk about very quickly is certificates, and literally it's as simple as this. You're done. You create a role alias, you attach it to your role, and your device can immediately use that role alias to access credentials. Now, ignore the man behind the curtain. There's a little bit more to it than this. There's a one-time setup where you've actually got to set up a trust policy, if you're familiar with trust policies, to allow IoT to do that. Obviously, you don't want IoT just arbitrarily assuming roles on your behalf and grabbing credentials. We're very, very security conscious. As Srini pointed out, security is a big part of it. But once you've got that done, that is essentially it, and your devices are off to the race. They pass in that role alias as part of their connection and request, and you're good. Create custom authorizer. It's really, really simple to get started with this. Just go into the IoT console, look under the security page. You see a couple of tabs, just click through. Really, really simple. The custom authorizer is pretty simple. It's got a Lambda function attached to it. What you put in that Lambda function is completely up to you. One thing I do want to highlight, though, is the public key. You might think, why do you want a public key? Well, one thing we do want to ensure is that that token that has meaning for you really is your token. And the only way we can absolutely guarantee that is if we've got some private public cryptography that we can prove, or you can prove that, yeah, this really is my token. So that's why that's there. Then you've got a token key that you use to identify it. And again, you set that up, you're off to the races again. Thing registration is cool. You can do single things, very straightforward, but as I talked about earlier, we've got bulk things. Do it in bulk. You can do it in line. Too easy to make mistakes, but it's there if you want it. The other thing you can do is pull it directly out of S3. Now, why is that interesting? That gets interesting because now you can version this stuff and you can see what changed. So you're starting to get into this DevOps model where it's almost deployment as code. I just made that up, but it's a thing, right? So literally, you can now start looking at your deployments and version control. So you can see at any point in time, I know I had 10 things. Why have I got 20 things reporting in? So really super interesting. Fleet indexing, yeah, this is a really complex one. You've got 3 radio buttons. It's either kind of on or off, and you've got a button to press. That's it. Now, depending on how many things you actually have, how many attributes, how many shadows, it's not instantaneous. I will confess it can take a little bit of time to get that millions and millions of things indexed. But once it's indexed, you're good to go. Super simple. Give me all the things starting with T. It is that simple a syntax, and you can get them out really, really simply. Obviously, again, console's not great for this because if you've got a million things that start with T, you've got a really, really long scroll bar. So again, but once you get into using the APIs and the SDKs, this becomes very automated. I can find me all the things that I want to get. I can write various parsers. You can even build a front end on it, tickle TK or whatever it happens to be. And then, of course, events. This is kind of pick and mix. We've got all the event types there. You can choose which ones you're interested in. You could send them all to the same topic. You could have different topics for different events. You turn them on, disable them, enable them at will, depending on how much information you wanted, what you were doing at that particular time. So again, you're very, very simple to use. And of course, my favorite is the jobs platform. Again, very simple to start off a job ID. Quick description, what's that job going to do? Couple of ways you can do this. Obviously, you can select the devices, the actual device. If we go back to our select statement, we could collect all these devices that matched a certain pattern, glob them up, apply them directly to our job, and say, this is the group of devices I want to do the job on. And then apply my job file, whatever that happens to be. And that's kind of free form. We're not prescriptive about what your job does. We don't make assumptions about which operating system, what language. You could run shell script in here. You could run Python code, whatever makes sense. You can pull down files from S3, whatever it happens to be. We support pre-signed URLs, so we get another level of security on top. If you want to apply it to all the devices, great. But you can apply it also to groups, and that gives us continuous jobs. And as I mentioned about there, the velocity, you can say how many jobs are we going to do at a time? How many executions of that job at a time? This is the technical term. Of course, we want to track it. What are my statuses? In this case, they're all just queued up to go. Nothing's really started yet because I didn't have a lot of things in my office. I've got a small cubicle at AWS. So, but you get a picture, and of course, you can get this through the API and do it programmatically as well. So in summary, what are we delivering? In onboarding, we've got our custom auth that Srini talked about. We've got our bulk provisioning for getting things configured en masse. We've got our ability to exchange our certificate for credentials. I want to organize all my things now. So we give groups, group policies for management. I can now search and index my entire fleet, find out the ones I'm particularly interested in. I can find out what they are up to. I can monitor my things. I can get information about them. I can log what they're doing. I can tie it to events. And of course, I can update it. So I didn't end up being like dying DNS. Some information there. This is the time you should take a photograph if you want a photograph. It will be on YouTube, but it's not going to be up there for 3 weeks. We do have an email alias where you can get more information. There's a forum. The forum started getting really busy yesterday, so I've got a lot of forum posts that I need to look at. And of course, we've got the developer guide that tells you how to use it and gives you information about the APIs and the various flows that you'll need to take advantage with that. With that, thank you very much, especially to Srini and Jim for coming up on stage. Thank you all for coming here. It was great talking to you all. Enjoy the party tonight.